students, now we will discuss about the communication protocols. On completion of this topic, students will be able to understand the basics of communication protocols. Communication. The communication is a very well known terminology which involves the exchange of information between two or more mediums. In embedded system, the communication means the exchange of data between two microcontrollers in the form of bits. This exchange of data bits in microcontroller is done by some set of defined rules known as communication protocols. If the data is sent in series, that is one after the other, then the communication protocol is known as serial communication protocol. Types of communication protocol: serial communication protocol and parallel communication protocol. Examples of serial communication protocols are CAN, Ethernet, I2C, SPI, RS-232, USB, one-wire and SATA. Examples of parallel communication protocols are ISA, ATA, SCSI, PCI, IEEE 488. Transmission modes in serial communication. There are several types of serial communication depending on the type of transmission mode and data transfer. The transmission modes are classified as simplex, half duplex and full duplex. Transmission modes in serial communication. Simplex method. In simplex method, either of the medium, that is sender or receiver, can active at a time. So if the sender is transmitting the data, then the receiver can only accept and vice versa. So simplex method is one-way communication technique. The well-known examples of simplex method are television and radio. Half duplex method. In half duplex method, both sender and receiver can be active but not at the same time. So if the sender is transmitting, then the receiver can accept but cannot send, and similarly vice versa. The well-known examples of half duplex is the internet, where the user sends a request for the data and they get it from server. Full duplex method. In full duplex method, both receiver and transmitter can send data to each other at the same time. The well-known example is mobile phone. Clock synchronization. The clock is different for serial devices and it is classified in two types, that is synchronous serial interface, asynchronous serial interface. Synchronous serial interface. It is a point-to-point connection from a master to slave. In this type of interface, all the devices use single CPU bus to share data and clock. The data transmission becomes faster with same bus to share clock and data. Also, there is no mismatch in baud rate in this interface. The well-known examples are I2C and SPI. Asynchronous serial interface. In asynchronous serial interface, the external clock signal is absent. The asynchronous serial interfaces can be seen in mostly long-distance applications and are a perfect fit for the stable communication. In serial interface, the absence of external clock source make it rely on several parameters like control, baud rate control, transmission control, etc. Baud rate. The baud rate is rate at which the data is transferred between the transmitter and receiver in the form of bits per second. The most commonly used baud rate is 9600, but there are other selection of baud rates such as 1200, 2400, 4800, 50,000, 7600 and 1,15,200. The more the baud rate will be fast and the data will be transferred at a time. Also for the data communication, the baud rate has to be same for both transmitter and receiver. Synchronous serial protocol. The serial peripheral interface, that is SPI, is a synchronous interface which allows several SPI microcontrollers to be interconnected. In SPI, separate wires are required for data and clock line. Also, the clock is not included in the data stream and must be furnished as a separate signal. The SPI must be configured either as a master or as a slave. The four basic SPI signals, that is MISO, MOSI, SCK and SS. VCC and ground are the part of data communication, so it needs 6 wires to send and receive data from slave and master. Theoretically, the SPI can have unlimited number of slaves. The data communication is configured in SPI registers. The SPI can deliver up to 10 Mbps of speed and is ideal for high-speed data communication. Serial Synchronous serial protocols. Most of the microcontrollers have inbuilt support for SPI and can be directly connected SPI supported device. Synchronous serial protocols, that is I2C serial communication. Inter-integrated circuit I2C, two-line communication between different ICs or modules where two lines are SDA serial data line and SCL serial clock line. Both the lines must be connected to a positive supply using a pull-up resistor. I2C can deliver speed up to 400 kbps and it uses 10-bit or 7-bit addressing system to target a specific device on the I2C bus, so it can connect to 1024 devices. Same like SPI, microcontrollers generally have I2C pins. Here we are having two masters and two slaves. Synchronous serial protocols, USB. Universal Serial Bus is widely used protocols with different versions and speeds. A maximum of 127 peripherals can be connected to a single USB host controller. USB acts as a plug and play device. The USB are used in almost devices such as keyboards, printers, media devices, cameras, scanners and mouse. It is designed for easy installation, faster data rate, less cabling and hot swapping. Synchronous serial protocols. USB protocol can be designed for two specific purposes: communicate with peripheral devices, supply power to the connected devices if applicable. Synchronous serial protocols. The CAN or Controller Area Network Protocol was conceived by Robert Bosch of GmbH in 1980s. Previously, during the late 70s, manufacturers started using advanced features in their automobiles such as anti-lock braking systems, air conditioners, central door locks, airbags, gear control, engine management systems and so on. The CAN bus system allows for central error diagnosis and configuration across all ECUs. CAN messages are prioritized via IDs so that the highest priority IDs are non-interrupted. Each ECU contains a chip for receiving all transmitted messages, decide relevance and act accordingly. This allows easy modification and inclusion of additional nodes. Example, CAN bus data loggers. The application includes start-stop of vehicles, collision avoidance system. The CAN bus system can provide speed of up to 1 Mbps. Asynchronous serial protocols. Asynchronous communication does not require a timing clock that is common to both devices. Each device independently listens and sends digital pulses that represent bits of data at an agreed upon rate. Asynchronous serial communication is sometimes referred to as transistor logic, TTL serial, where the high voltage level is logic 1 and the low voltage equates to logic 0. Almost every microcontroller on the market today has at least one universal asynchronous receiver transmitter UART for serial communication. The examples are RS-232, RS-422 and RS-485, etc. Ethernet. A local area network LAN is a data communication network connecting various terminals or computers within a building or limited geographical area. The connection between the devices could be wired or wireless. Ethernet token rings and wireless LAN using IEEE 802.11 are examples of standard. Ethernet. Ethernet technology provides rules that one another without packing collisions. Ethernet is mostly widely used LAN technology and is defined under IEEE standards 802.3. The reason behind its wide usability is that Ethernet is easy to understand, implement and maintain all and allows low-cost network implementation. Also, Ethernet offers flexibility in terms of the topology that are allowed. If two or more devices connected on a sharing network attempt to transmit data packets at the same time, a packet collision occurs. Ethernet network that are used to connect devices and transfer data. Fast Internet, Ethernet. Fast Ethernet uses both fiber optic and twisted pair cables to enable communication. Gigabit Ethernet. It can transfer data of up to 1000 Mbps or 1 Gbps. 10 Gigabit Ethernet. This is an advanced and high-speed network that can transmit data at a speed of 10 gigabits per second. With the help of fiber optic cables, this network can cover longer distances up to around 10,000 meters. Ethernet network that can be used to connect and transfer data. Continuation. Switch Ethernet. This type of network involves using switches or hubs to improve network performance. Each workstation in this network has its own dedicated network connection, which improves the speed and efficiency of the data transfer. Advantages of Ethernet: speed, efficiency, good data transfer quality. Disadvantage of Ethernet: distance limitations, bandwidth sharing, security vulnerabilities, complexity, compatibility issues, cable installations, physical limitations. Thank you.